Hi everyone. So today we are going to discuss a problem that appeared in RMO 1998, which involves reflecting the vertices of a triangle in the opposite sides and proving its equilateral. Now, for that doesn't happen generally, but in this case, it is an isosceles triangle with vertex angle 30. So let's see a picture of such an isosceles triangle. Okay, so here's a GeoGebra picture of it. Now let's try to reflect the vertices A, B, and C in the opposite sides. Okay, so you'll get a picture like this where A dash, B dash, C dash are the reflections of A, B, and C respectively. Okay, so it does look like an equilateral triangle, right? A dash, B dash, C dash does form an equilateral triangle. Okay, so we have to prove that now. Why does it happen? Okay, so let's see why. So the way to solve this problem is to just understand how reflections work. That's all. Okay. All right. So let's first reflect vertex B about AC. Okay. So if you look at vertex B here, when you reflect it about AC, what happens is that if you take the line joining B and C, that also reflects here on the other side. Okay. So by the way, you don't have this base line right now. What you have is this line, and which then reflects to that line. But remember, when you reflect, these angles become equal. Okay, so this angle is 60 degree. So you have a 60-degree angle and it's bounded by two lines which are equal. Okay, so there's a 60-degree angle in between two sides which are equal. So therefore this particular triangle B dash C BC becomes an equilateral triangle. Okay, because this is equal, this is 60. All right, so let's fill that in. And here's a running theme in this video. Notice that if any two line segments in the drawing are of the same color, that means that these two line segments are congruent. Okay, so this line segment and this line segment and this line segment and this line segment, these are all congruent. All the green segments have equal length. Okay, all right. So we know, by the way, we also know angles. I think it's good to mark all the angles. It's useful, it'll become useful later. So this is 60 degrees. By the way, a quick note is that if you are in a situation of an isosceles triangle with the base angle, vertex angle 30, then we know that these angles are 75 and 75 by angle sum property and the fact that base angles are equal. All right, so indeed, we know the entire thing is 75 here, okay, 75, which means that the remaining angle here is 15. Okay, so that's good. So we'll get a similar equilateral triangle on the opposite side as well, because reflection of A dash is reflection of A is A dash, so AC A dash again forms an equilateral triangle. So let's draw that. Let's draw the reflection of. Let's join this. More green segments. Notice that again you have all green segments because an equilateral triangle and already AC is green. So we have 5 green segments at this point. Okay, awesome. So further we also know this is 30. Which means 30 plus 30 plus 30, this is 90. Okay, that also we know. All right, let's move on. Now that we have made all these observations, what more do we have to do? We have to reflect C about AB, right? We have not thought about that yet. Again, when we reflect, we'll get more green segments, because when you reflect C to C dash, these two lengths will become equal, right, under reflection. So let's see that. Okay, so you get more green segments. Okay, yes, you get more green segments. But what about the angles though? Well, recall that this angle was 75. Okay, so let's look at the angles carefully. This is 75, and when you reflect, this also is 75. Okay, and this entire angle is 60. So let's see that. This entire angle from here to here is 150. Okay, so you have this entire angle that is 150. Okay, and we know that this angle is 60. Okay, so now if you subtract, we know this angle is 90. Okay, so we know this angle is 90. We know this angle is 90 already on the top. And symmetrically, just like we know this angle is 90 on the left, here we know this angle is 90. On this side also we have a 90 degree angle. Okay, now is the key point. Notice what we have. We have here two segments which are green and their included angle is 90. So if you complete the triangle, okay, this black line is the opposite side of the isosceles right angle triangle with green sides and included angle 90. The same thing is happening here. Notice this is a green segment, the included angle is 90, which means by congruence of triangles, this is also a black line segment, meaning they are A dash B dash and A dash C dash are congruent. And very similarly again, B B dash and B C dash here are again both green and their included angle is 90 symmetrically. So you have another black segment. So you have therefore an equilateral triangle. Okay, so let's see how that works. As you can see, here's an accurate picture showing those are congruent. Pink triangles are congruent, and then therefore you have your equilateral triangle. Okay, I'm done. So see you. Bye.